What you see here is I have a little test tube that I just kind of have in a science kit that we have here. And I have filled it with 3 milliliters of water. So I've kind of jumped ahead on this lab. So the very first thing that I would like for you to do is I would like for you to read this lab, the background, okay? And it's talking about the different phases of matter. I really want to bring your attention to this diagram right here. This diagram, you guys, is so important because you see, we're showing the particle diagram of ice, then liquid water, and then water vapor, and the phase changes. So we're looking at what's happening at the microscopic level. So when I'm talking to you about those particle diagrams, that's what I'm talking about, something looking like that, okay? Now, as you read down, you will see that what we're doing is we are taking our first setup and we're going to freeze water, and then we are going to melt ice. So we're going to start a new experiment on the data collection system, and that's what I've got right here is SparkView. So I've already got that set up for you. And then we're going to connect the temperature sensor to the data collection system. So the temperature sensor is going to be this sensor right here that I have, and it's stuck in the water, and it's going to record the temperature. So it's recording that temperature of the water. I can see on my screen, if you look on the right-hand side, as 25.6, 25.5 degrees Celsius, okay? And that's what we're looking at right here. So the next thing I'd like for you to do is, and I have this set up, the temperature versus time graph, and I would like for you to predict what a temperature versus time graph is going to look like. So is the temperature going to go up? Is the temperature going to go down when I'm taking water and I'm going to freeze it? Then I want you to predict what a temperature versus time graph will look like for when I melt the ice. Is the temperature going to go up? Is it going to go down? Is it going to stay the same? Okay. So after you've done that, go ahead and continue on down this lab. Okay. So what I've done is I've also highlighted the questions for the first part of the lab. So it says, use a graduated cylinder to measure out 3 milliliters of distilled water. And luckily, this little test tube, it comes from a kid's science kit. And so it actually has milliliters. It has the measurements on the side. So I measured out 3 milliliters of water. And then it says, fill a beaker halfway full of ice. So I'm going to use this cup right here. And I'm going to fill it with, I have it with ice. And then I'm going to put, it says rock salt, but I'm actually going to end up using Epsom salts. So Epsom salts would work just fine. Epsom salt is made up of magnesium sulfate. I'm going to go ahead and add that to my ice. Okay. And I'm going to stir that so that it's a nice mixture of salt and ice. And I'm going to hit start over here. I'm going to start my experiment, start recording my temperature, and I'm going to stick this right in here. Okay. And what I want to do is I want to get this so that it's starting to melt. Okay. So the ice is starting to melt on the outside, and while that's happening collectively on the inside of my test tube, I'm getting the water in the test tube to freeze. And if you've ever touched ice and salt, I don't necessarily recommend it, but if you've ever touched ice and salt, you know that that's super cold. So this little device right here, it's just recording. It's recording my temperature. So if you look on the right side of my screen, you can see what's happening to that temperature. And I'm just going to let it run while I read off the procedures for you. So we've already filled our beaker halfway full of ice, and we've added our 2 spoonfuls of rock salt. We've used, instead of a stirring rod, I've got like a little straw right there. And it says, place the test tube containing the temperature sensor into the ice and salt mixture and start your recording temperature data. And then it says that I might need to adjust the scale on the axis. And I'm going to actually adjust that a little bit later. Okay. And then gently stir the mixture with the test tube. Keep the temperature sensor positioned so the tip freezes in the ice. So I have my tip is definitely inside of that water, okay? It goes all the way to the bottom of that test tube. So I have that there, and you'll see, I mean, my temperature is dropping quite a bit. I went from 25 degrees, now I'm at 17.2, 17.1, and I'm continuing to drop. And it says, carefully add more ice around the test tube and 2 more spoonfuls of salt. Gently stir the mixture with the test tube and keep the temperature sensor positioned so the tip freezes in the ice, okay? So I'm going to go ahead and keep running this until my temperature gets to around -6 degrees Celsius, or maybe even a little bit lower. So I'm going to keep running it. I'm going to stop the video, and then I'm going to come back to you as I'm getting closer to that point, okay? So I'm going to tell you right now, it is 7:09 when I'm doing that, and I'm going to try to remember to check in with you the time that it is so you can see how much time it took. Or you can go ahead and look at your scale right here. So this is a measurement of time, and that measurement of time is in seconds. At -1.4 degrees Celsius, and I'm still running, okay? So I've been running for 8 minutes and 55 seconds. And I'm just gonna let it keep going and see what ends up happening to my graph over time, okay? But notice that you're starting to see this in this situation. So when I have my my thermometer right here, I still have water there, okay? So I don't have frozen water. I don't have ice. I just have really, really cold water, okay? So we're going to keep running this, and I'm going to keep adding ice. A little bit of ice and a little bit of salt at a time. And we're still at that -1.7, which is kind of interesting because it's kind of stayed at that -1.7. So now we're at 1.8, 1.9, -1.8, -1.9. And so we're still going, -2.2. But you see how that line has gotten, it was very steep at first, and now it's not so steep anymore, okay? It's not so steep anymore. And so I wonder why that is, why there is not that deep change, okay? So we're still moving. Okay, so you can really, this is a great picture of this graph. You can really see that that temperature has really just kind of plateaued, okay? It's really going to that straight line, okay? So what do you think that straight line is showing? What's happening at this straight line, okay? What do you think is happening at that straight line? I'm gonna see if I can move. I can still move my thermometer around a little bit, okay? But it really feels like it's starting to freeze in there. So I definitely have frozen pieces in there. Okay. So we're still at that -2.8, 2.7, 2.8. We've really just stayed there for a little while. Okay. So I'm going to go ahead and come back when this graph is finished. But what's happening at this point is I'm getting to the point where it's a little bit harder to move my thermometer around. Okay. It's getting a little bit harder. I've definitely got some frozen pieces in there. Okay. So I'm going to come back when it is all frozen and this graph is finished. Okay, so here you can see what our final graph looks like. And what I've done is I've expanded it, and I've also relabeled it as water freezing. And I've also marked this plateau here at negative 2.9 degrees Celsius. Now, something for you to note is that water freezes at 0 degrees Celsius. But what's also important to note is that at that freezing point, which I realize this is lower than 0 degrees Celsius, but at your freezing point, all of a sudden your graph just starts to flatten, okay? And it stays flat, and it stays flat until ice has formed completely. There is no more water at all, only ice is there, okay? And then the temperature can start to dip after that. Okay, so here I am with our next part where you see right here, it says start recording from another or recording another run of data. Remove the test tube from the salt and ice mixture and place it in a test tube rack. So I actually just have it sitting here in this room. And I am running, if you look on the right side of my screen, you can see that I'm already running data. And so I'm going to go ahead and run this data right now. So if I click on that window, so you can see I'm running at 0.6 centigrade Celsius. And when I'm running at I'm running all of this time, it's running at 0.6, 0.7, 0.6. So it's staying pretty constant. And if you look really closely, you can see that that thermometer is only in ice. So while we're waiting for that to melt, the ice to melt, go ahead and answer these questions. It says, what are the independent and dependent variables in this experiment? So let me just remind you that the independent variable is what you are changing. That's usually your input in math. That's usually your X value. So what is your X value? If we look at this graph over here, if we look at this graph right here, what does it say? Our X value, okay? And then it says, what is our dependent variable? Our dependent variable is usually our Y-axis, okay? Then it says, record the temperature at which the water froze and ice melted. So for this one, you're going to record, it's kind of just staying at that 0.7 degrees Celsius. And then the last part of this, you saw that it was at like negative 2.9. The freezing point, the actual recording freezing point and melting point of water is actually going to end up being 0 degrees Celsius, okay? But something I really want you to see is, do you see that flat line? Look at how flat that is. Now we're at 0.8, but come on. You look at that and you see, that's just because we're dealing with ice melting, okay? And so for this, we're going to actually run it until it's at 10 degrees, between 8 and 10 degrees Celsius. So I'm going to actually take the warmth of my hand and I'm going to put my hand around this, okay? What's that going to do? What's that going to cause that ice to do? Okay, think about that. We can just know just from our experiences what that's going to do. And we're just going to sit there and we're going to let the ice melt. So I'm going to go ahead and stop this video and I'm going to come back in a few minutes when that ice is fully melted. And I'm going to try to start the video right around when there still is just a little bit of ice, okay? But notice I'm going to start stirring here, okay? Stirring in this situation, okay? So I'm going to come back in just a few minutes when we have our ice has melted, okay? Okay, so what you're seeing here is you're seeing my ice after it has melted. And this right here is what my graph looks like after that ice is melted. So I'm going to go ahead and stretch my graph and you can really let me move this out of the way. You can really get an idea for what that graph looks like. So you kind of have this plateau right here. It's kind of a plateau. And then all of a sudden, really it just starts to go up right here, okay? And obviously you're going to end up having a little bit of error there. But the most important thing to see is that the phase, while the phase is changing, you have a relatively flat line. Now, if we were in a perfect lab situation and there was no error and there were no issues, then in this would be completely flat, and it would be completely flat at 0. And then as soon as all of that ice melted, it would start to plateau. It would start to go up in a slope. Okay, so that's something important for you to see, is that if we were in a perfect lab situation, then we would have this as a flat line, and then we would slope up, okay? So when we look at the lab and what we're supposed to do in the lab, it says you're going to go ahead and answer these questions first. Where does the heat come from, which causes the ice to melt? So where did that heat come from, okay? What caused the ice to melt? And then after we've stopped recording the data, what we're going to actually have to do is we're going to have to take a screenshot of this and we're going to embed it in the slides below. So that's actually what I'm going to do. So I'm going to take a screenshot of my data and then I'm going to put it in to your data table for you. Okay, so in this last part of this activity, we're going to boil water. So the very first thing that it says is to ensure that the data collection system is on and that the stainless steel temperature sensor is connected. So I have my stainless steel temperature connector and I can tell because there's a little flashing dot there. And I'm going to title this boiling water. And I want to make sure that I have my temperatures in degrees Celsius and my time is in seconds. Then it says turn on your hot plate to its highest setting. So I actually already have that done. I've already started that process. And it says that this generally takes 2 minutes. Allowing the hot plate to warm ensures that a constant amount of heat is added to the beaker of water. If you did not allow that hot plate to warm up, what do you think would happen? And then why do you think that we should set it at the highest setting? So what are your answers there? And then move down. And it talks about attaching a utility clamp. And like I've talked to you guys about, I'm going to use the material that I have. So I have a beaker that I brought with me. And I am just going to hold this thermometer in there. And I'm going to end up hitting start. And I'm going to let it record for a little while. Okay. Notice the most important thing when you're taking a temperature is you want to make sure that your thermometer is not touching the walls of the container and is definitely not touching the bottom of the container. So if I look at this, and I'm actually already going to stretch that graph a little bit, okay, because I want to see what's happening to my data, okay? And I'm going to actually expand that in just a moment, but I'm going to go through and make sure that we've answered these questions. So I'm going to keep continuing to heat this until I've seen bubbles for about 8 to 10 minutes. And I actually might not keep it going for that long, but I am going to keep recording. I'm not going to keep this on the screen the whole time. I'm going to keep recording and then I'll show you what the graph looks like after that. But why is it important for the temperature sensor to remain in the center of the water? So why do you think that's important? Why do you think it's important that I don't touch the side of the container or the bottom of the container? What do you think is the most important part of that? Okay. And then what are the independent and the dependent variables? So this is, I'm not going to discuss this with you verbally. You can go back in this video or you can look back at your last answer. But what determined if something was an independent variable versus a dependent variable? And I would go ahead, I would make sure that you know how to answer that because I can guarantee you that that will show up on your guys' quiz. So record the temperature when you observe the water is at a vigorous boil, and why is it necessary to boil the water for so long? So that's something that I'm going to go ahead and pause for, and I will come back in just a moment so that we can finish watching this graph after it's been boiling for quite some time. Okay, so I would like for you to see now what's going on. So at this point, we have our temperatures at 96.5, 96.6, 7, 8. So the temperature is definitely climbing, okay? It's definitely climbing and you see a lot of bubbles. Now, that's not necessarily the boiling point. You have some of the gas that's trying to escape. Question for you while we're waiting for it to completely boil. Tell me, what do you think fills those bubbles? What do you think fills those bubbles? A lot of people will say H2 and O2, but do you really think it's H2 and O2? What's really changing? You have H2O liquid is becoming H2O what? H2O liquid is becoming H2O what? Okay? And so now you can see that we have a very rigorous boil here. We have a very rigorous boil. And something that I can tell you right now, if you looked at the temperature is 98.4 and it is not changing at all. So something I'll tell you while we're waiting for it to boil for a little while longer is, remember back in the very first experiment when we were at negative 2.9 degrees Celsius and we were off just a little bit. Something is telling me that this thermometer is off by just a couple of degrees, okay? Because we would expect this boiling point, this flat line, to definitely be at 100 degrees. So water boils at 100 degrees Celsius, but that's what we have going on. I mean, we have the boiling, and notice it's so crazy. That temperature is not changing, okay? That temperature is not changing. And we're going to sit here and boil it and boil it and boil it, and that temperature is not going to change, okay? So I'm going to let it set here for a few minutes. I'm going to stop sharing and I will check back with you in a few minutes to see where we're at. So here we are about 7 minutes later, okay? 7 minutes from the point that it started boiling, I apologize. And I'm still recording 98.3. So again, I want you to hear this from me though. This thermometer is not calibrated. This thermometer needs to be calibrated, and that's something that we need to do when we go back to school. It's not something that I'm going to mess around with right now, but it is off by about 1.6 degrees Celsius because I know that water boils at 100 degrees Celsius for sure. Now, notice, look at that flat line. You guys, I think that this is a lab, and this is why I'm doing this lab. This is why I'm recording it. This is a lab that you really don't believe it until you see it. Look at that flat line. How long do you think that flat line is going to maintain? That flat line, how long is it going to maintain? It's going to maintain as long as there's water there to boil, until all of that water has been turned into vapor. The liquid water has been turned into vapor. It is going to stay the course on that flat line because the temperature does not change during a phase change. And that is by far and away the absolute most important message from this lesson today, is that the temperature does not change during a phase change. The temperature changes when we're adding energy and the phase is not changing, but the temperature does not change during a phase change. But you see how hot that hot plate is. I am still changing the energy. I'm still adding energy. So that's my next question for you is, where is that energy going? What is the energy going to in order, like, why is the temperature not changing? We've already talked about temperature is kind of a measure of that, the velocity of the particles. So why is it that that temperature is not changing when I'm adding energy to it? Okay, think about that. And that is something that's the most important thing that we're going to discuss in our Zoom meeting, our second Zoom meeting this week. So while that's going, I'm actually going to go ahead and hit stop for that recording because I think that we have enough data. Okay. And then the next thing that I'm going to do is I'm going to go ahead and take a screenshot of that data. So I am going to check back in with you in just a second. Okay, so what I am going to do now is I'm just going to show you the very last part of this lab. You are responsible for filling in the data for this lab and the information for this lab, okay? We have actually answered all of these questions except for this is a question that I think is really, really good. Why is it necessary to boil the water for so long, okay? If you look back at your very first graph, and if you're not sure what that looks like, it's actually below a little bit. But if you look back at your first graph, when we melted the ice, when we melted solid water to liquid water, that line was really small. Now, granted, I will say I had a whole lot less material, right? I had less material, I have less water. However, it takes a whole lot longer to boil off water than it does to melt solid water. Why do you think that is? Why is it necessary to boil the water for so long? Why do you think that is? Okay, I love that question. Now, as you scroll down, you will see I have already embedded the graph for part 1, I have embedded the graph for part 2. And part 3 is right here. It is blank. So I'm going to actually show you how I'm doing that. Okay. I'm going to go ahead and delete this graph. And I'm going to come over here to my Spark view. I'm going to make it a full screen. And I am going to hit my Window Shift S. And that's going to allow me to take a screenshot of this data. Okay. And then I'm going to take that data and I'm going to embed it right here. So I'm going to hit Control V, which is basically going to paste that data. And I'm actually done with my SparkView software. So I would like to implement the SparkView software when we get back to school. But for right now, that was me just walking you through the SparkView results. So what we're going to do now, or you are going to do, is you're going to answer these analysis questions based on all of your observations. Answer these questions and tell me what you think, and then you're going to answer some multiple choice questions at the very end. Finally, you're going to fill in some blanks of an essay, it's like an essay, but it's like a fill in the blank essay. And then you're going to find a diagram online, or you are going to use a drawing to fill in this. There's going to be a table right here that you're going to go ahead and fill in. And you're going to fill that in for the full cooling or heating curve of water.